Hello students, in this video I'll be discussing about some of the questions and answers related to the topic X-ray machine. In the end, I'll be discussing how the X-rays are formed in an X-ray machine. Welcome you all to Oral Medicine and Radiology Made Easy. Please like this video and subscribe to this channel. First question, what are the component parts of an X-ray machine? The parts of an X-ray machine are control panel, extension arm and tube head. So this is the control panel. This is the extension arm which connects the control panel to the tube head. Control panel consists of on and off switch, an indicator light, exposure button and the controls that regulate the time, kilovoltage and milliamperage. The extension arm suspends the X-ray tube head and houses the electrical wires that extend from the control panel to the tube head. So these are the three parts of X-ray machine. What are the components of tube head? Tube head consists of a metal housing. This is the metal housing inside which we have the insulating oil, tube head seal. This is the tube head seal, X-ray tube, transformer, aluminum disc which acts as filter. Then there is a lead collimator which limits the size of the X-rays and position indicating device. These are the components of tube head. Third question, what is an X-ray tube made up of? The X-ray tube is made up of leaded glass. So this is the leaded glass which prevents the leakage of X-rays from the X-ray tube. What is cathode in an X-ray tube consist of? Cathode is negatively charged. It consists of a filament which is made up of tungsten and a focusing cup. These are the two parts of cathode in an X-ray machine. What's the distance between cathode and anode? The distance between the cathode and the anode is less than half an inch. What is anode consist of? Anode is positively charged and it consists of tungsten target embedded in a copper stem. So this is the tungsten target which is embedded in the copper stem. Why are X-ray tubes called as Coolidge tubes? All dental and medical X-ray tubes are called Coolidge tubes because they follow the original design of W.D. Coolidge introduced in the year 1913. What is the function of power supply in an X-ray tube? For the X-ray tube to function, a power supply is necessary to heat the filament to generate electrons. So this filament needs to be heated up to generate electrons and to establish a high voltage potential between the cathode and the anode to accelerate the electrons. What is the source of electrons in an X-ray tube? The filament present in cathode is the source of electron in an X-ray tube. What is filament in an X-ray tube made of? The filament is a coil of tungsten wire which is about 2 mm in diameter and 1 cm or less in length, coiled to a spiral of 0.2 cm in diameter. So it is mounted on two stiff wires that support it and carry the electric current. So the tungsten wire, which is of dimension around 2 mm diameter and the length is 1 cm or less than that. So this tungsten wire is coiled in a spiral form and the diameter of this spiral is around 0.2 cm. So the diameter of the tungsten wire is 2 mm and this spiral has a diameter of around 0.2 cm. What is thermionic emission? The emission of electrons from a metallic filament when heated to incandescence. That is, when the filament is heated to incandescence, it releases electrons. This is called as thermionic emission. What is focusing cup? Focusing cup is a negatively charged concave reflector made of molybdenum. The purpose of focusing cup is to reflect the electron that is emitted from the tungsten coil, and this is made up of molybdenum. Why the X-ray tube is evacuated? X-ray tube is evacuated to prevent collision of the moving electrons with the gas molecules, which would significantly reduce their speed. So if the air molecules are present within the X-ray tube, the electrons which are produced at the cathode will collide with the gas molecule, and hence their speed would be significantly reduced, and also prevents the oxidation and burnout of the filament. So evacuation prevents oxidation and burnout of the filament. Why target is made up of tungsten? Target is made up of tungsten because of its characteristics of an ideal target material. That is, it has a high atomic number, it has high melting point, it has high thermal conductivity and low vapor pressure at the working temperature of an X-ray tube. So these are the characteristics which make it suitable to be a target material. Why copper is used in anode? Tungsten target is embedded in a large block of copper to dissipate heat. And copper is a good thermal conductor and dissipates heat from the tungsten, thus reducing the risk of target melting. What is focal spot? Focal spot is the area on the target to which the focusing cup directs the electrons from the filament. What is the relationship between the sharpness of the radiographic image and size of the focal spot? The sharpness of the radiographic image increases as the size of the focal spot decreases. So they have an inverse relationship. So as the focal spot size decreases, the sharpness of the radiographic image increases. What is the disadvantage of having a small focal spot? The heat generated per unit target area becomes greater as the focal spot size decreases. So when the electrons from the cathode hit the target, 99% of its kinetic energy is converted to heat. So if the focal spot size is less, then the heat generated per unit target area becomes greater. What is the size of actual focal spot and effective focal spot? The size of the actual focal spot is 1 into 3 millimeter, whereas the size of the effective focal spot is 1 into 1 millimeter. What is Benson line focus principle? The target face is placed at an angle of 15 to 20 degrees to the cathode. So as the target face is made larger, the projected spot becomes smaller. The effect is that small apparent source of X-rays and an increase in sharpness of the image with the larger actual focal spot for heat dissipation. As we learned in the previous slide, the sharpness of the image increases as the focal spot size decreases, but we need a larger focal spot for efficient heat dissipation. So in order to achieve that, target is kept at an angle so that the effective focal spot becomes smaller, but the actual focal spot remains at a larger size for a effective heat dissipation. So use of an anode with the target angulated such that effective focal spot is smaller than the actual focal spot is referred to as line focus principle. So here we can see, so from the cathode, the electrons will strike the anode, but focal spot is the area where the electron strikes on the anode. This region is at an angle so that the effective focal spot for the electrons to strike is around 1 millimeter, whereas the actual size of the anode is 3 millimeter. So this is line focus principle. So the angulation given to the focal spot allows better heat dissipation. At the same time, emergent X-ray beam is narrow, which contributes to the sharpness of the image. What is an approximate area of effective focal spot in a dental X-ray tube? The approximate area of effective focal spot in a dental X-ray tube is 0.5 to 1.2 millimeter square. What is Heal effect and what's its significance? So intensity of X-ray beam that leaves the X-ray tube is not uniform throughout all the portions of the beam. So X-ray beam on the anode side of central ray has low intensity due to self-absorption of photons in the target. This variation is called as Heal effect. So effective focal spot size may be decreased by reducing the angle of anode with respect to the central ray. However, in practice, this is limited by Heal effect. So here we can see this is the anode, and towards the anode the intensity is less because the photons from this ray are absorbed by the anode. So because of this self-absorption of photons by the anode, the intensity of the X-ray towards the anode is less compared to those towards the cathode. So if you further reduce the target angle with respect to the central ray, there will be more absorption of the photons on the anode side, and hence the intensity of X-rays will reduce. So this is called as Heal effect, and Heal effects limits the angulation given to the anode. What are the two types of circuits used in X-ray tube? A circuit is a path of electric current. Two electrical circuits used in the production of X-rays are filament circuit, which uses 3 to 5 volts, regulates the flow of electrical current to the filament of the X-ray tube, and high voltage circuit uses 65,000 to 1 lakh volt and provides higher voltage required to accelerate electrons to generate X-rays. What is a transformer? Transformer is a device used either to increase or decrease the voltage in an electric circuit. What is the function of step-up and step-down transformer in an X-ray tube? A step-down transformer is used to decrease the voltage from the incoming 110 or 220 line voltage to 3 to 5 volts as required by the filament circuit. And a step-up transformer is used to boost the peak voltage of the incoming line current 110 or 220 volt to 60,000 to 1 lakh volt, 60 to 100 kV. So this is a step down transformer where the incoming current is reduced to 3 to 5 volt from 110 volt. This is required by the filament circuit. Whereas in the step up transformer, the incoming current is increased from 110 volts to 60,000 to 1 lakh volt. This is called as step-up transformer. What percentage of kinetic energy of electrons is converted to X-rays, and what happens to the rest? Less than 1% of kinetic energy of electrons is converted as X-rays. Rest 99% liberated as heat. The last question: how the X-rays are produced? When the X-ray machine is turned on, electrical current enters the control panel through the cord plugged into the wall outlet. The current travels from the control panel to the tube head through the extension arm. The current is directed to the filament circuit through the step-down transformer. So from the control panel through the step-down transformer, the current is directed to the filament. Using this current, the filament is heated and it releases electron by thermionic emission. These electrons stay in the electron cloud until high voltage circuit is activated. So these electrons remain in the cathode region, forming an electron cloud, and remain at that place till the high voltage circuit is activated. When this exposure button is pressed, a high voltage circuit is activated. Electrons produced at the cathode are accelerated towards the anode, and the molybdenum cup, which is present at the cathode, directs the electrons to the tungsten target. When the electrons strike the target, the kinetic energy of the electron is converted to X-rays. 1% forms the X-ray and rest 99% is lost as heat. So the heat that is produced during the production of X-rays is carried away by the copper stem and is absorbed by the insulating oil. X-rays produced are emitted from the target in all directions. Here you can see how the X-rays are emitted in all the directions. However, leaded glass housing prevents X-rays from escaping. Because the glass is leaded, it prevents the escape of X-rays in all the directions. A small number of X-rays exit from the X-ray tube through the unleaded glass window portion. Here there is a tube head seal and aluminum disc. So at this part there is a tube head seal and a aluminum disc. This part is unleaded. Hence it allows X-rays to pass through it. The aluminum disc removes the longer wavelength X-rays, and the size of the beam here is restricted by lead collimator. So this is how the X-rays are formed. So here you can see how step down transformer heats up the filament and it releases the electron. Once the exposure button is pressed, high voltage circuit is activated and it creates a potential difference between cathode and anode. Electrons move from the cathode towards the anode and the X-rays are produced. With this we come to the end of this video. Thank you.